I'm going to be talking a little bit about the future of in-memory computing today. And I'm not going to go back to the beginning of in-memory computing. I thought I'd just go back a few years. So I'll take a look back into 2017. I think that's far enough back for today's purposes, and look at what we were talking about then. I'll take a look at where we are today with the state of in-memory computing, and then make a few predictions about the future. And along the way, I'll try and point out some of the talks that you'll have an opportunity to hear today and tomorrow, and how they tie into some of the developments in the in-memory computing space that that may be of particular interest, depending on your particular interests. And then also at the end, I'll tie this together a bit for what this means for you. So we'll start with yesterday. So going back a few years to 2017, the future was bright. So according to Gartner, in their hype cycle for in-memory computing technologies that they published in 2017, they talked about the digitalization of business generating an inexhaustible demand for faster performance, greater scalability, and deeper real-time insights, which was boosting innovation around in-memory computing technologies. And of course, if you're familiar with Gartner hype cycles, they also have a curve for hype cycle technologies, and it was interesting. So looking back at 2017, they were pretty much spot on for quite a number of these technologies. So just a few I thought were notable and that are very relevant for today. Some of the technologies they said were 2 to 5 years out include in-memory data grids, which you'll hear a lot about today and tomorrow. In-memory computing enabled application infrastructure, again, a hot area. Analytical in-memory databases. So obviously that's something that there's a lot of interest, kind of real-time, high-performance analytical databases. Same with operational in-memory databases. So those are really starting to take their place, especially for greenfield applications. 3D crosspoint. So we're going to hear a lot about persistent memory today and tomorrow. So again, pretty spot on in terms of the timing for their projections, and of course Spark, which again has done very well and really taken off in terms of adoption. Some of the other technologies, just a couple that I found interesting. So in the 5 to 10 year time frame, they were talking about real-time analytics. It's kind of interesting with some of the other developments that have happened over the last 3 years, maybe how that fits in with some other things that have developed that might bring some real-time analytics capabilities closer in than 5 to 10 years out, and also in-process HTAP. So that's essentially databases that can do both operation or transactional and analytical processing on the same data store, but also in real time react to conditions around them to drive better business processes. So again, maybe something that we're starting to see already with some of the other technologies that have developed that really weren't on the hype cycle or really in the common thinking back in 2017. So, you know, one of the other things that has happened since 2017 is digital transformation has really become a thing. And we hear about it all the time now. Boston Consulting Group defines digital transformation as a fundamental change, a metamorphosis in how companies generate value for their owners and other stakeholders by applying digital technologies and ways of working to all aspects of the business, which is, I thought, a pretty good definition. Obviously, lots of companies are undergoing digital transformation. There's a lot of talk about digital transformation. It's certainly something that we're seeing a lot of interest in, and really that's driven by the changes in expectations for real-time, seamless customer interactions. So, you know, companies really rethought about how they interact with their customers. They want the customers to have a seamless interaction, whether they're interacting with them online, in a store, or on a mobile app, anywhere. They'd like that interaction to be seamless to the customer, so the customer always sees their most current information across all the company's touch points with the customer. Part of that, though, is the real-time business processes require real-time access to all data for a specific customer across the enterprise in order to enable those kinds of interactions. You need a 360-degree view of the customer in order to really have an effective interaction with them across all touch points. And it's part of what happened is it became apparent that monolithic, asynchronous, ETL-based applications and processes that are drawing from data silos presented a barrier. That was one of the barriers that really became obvious as companies were trying to digitally transform. They're trying to run real-time business processes, and they're trying to have these great seamless interactions with their customers. And interestingly, one of the challenges is that data stores have been proliferating. So not only do we have more and more data stores, not only internal databases, application databases, but maybe SaaS solutions that you're using. There's multiple places where data gets stored, and these disparate data sources may not be accessible or easily accessible in current architectures. There may be limitations to APIs. There may be costs to calling on these data stores. And one of the very interesting findings, this is some research from 451 research, is that actually the most data-driven companies also have the most data silos. So the most data-driven companies there are in orange, and you can see they really have significantly more data silos than just the average company. So this presents some real challenges. How do you make that 360-degree seamless view of the customer when you've got data spread out all over the place and you can't easily pull it together? And of course, since 2017, some other things have popped up, right? So obviously we're all dealing with COVID, but that's made some real changes in business. E-commerce has increased. There's a lot more logistics challenges now, from getting your food from DoorDash to all those shipments that are coming from AWS, and all those shipments from suppliers from all over the world. There's also tremendous growth in the number of remote workers. So there's all kinds of new challenges in terms of connectivity and communications that have popped up. And of course, 5G has been rolling out since 2017, which not only presents new opportunities for telcos, but it's also empowering whole new fields of opportunity. I remember with the Internet of Things, we used to attend a show that was, I think it was IoT World, and it was a separate show. But now IoT has just become part of business. So it's really morphed from kind of something that was a solution looking for an application to really just being part of business now. So IoT's come along, digital twins have the idea of digital twins and how you apply that to business and use all this data from potentially sensors all over the place to make your business run better has really grown has really grown. And also edge computing, another area where dealing with all this data. Do you really want to move it all across the network? Do you want to process it in place and just move part of it, move results? All these areas have started to really emerge, and 5G is really powering a lot of that. So that brings us to today. So where are we today with in-memory computing? Well, the first thing I think we would probably all agree on is that in-memory computing has really crossed the chasm. So really at this point, we've gone from difficult technologies and challenges to figuring out how to use it, to really the early majority of adopters really starting to fuel the growth of in-memory computing implementations and usage within the markets. So the business needs are really driving widespread adoption, and it's a number of those new and emerging needs that I just talked about that really help drive this. So companies, they need to make their business more responsive. They need to have better customer interactions, and they need solutions for doing that. And in-memory computing is one of the solutions that can make a lot of that possible. At the same time, as you move into the implementation phase, demand has really grown for deployment-ready solutions. It's no longer difficult bleeding edge technologies that people really are looking for. They're looking for things that they can take and they can deploy, and they can use skills that they have or they can acquire to really get the rapid return in investment in implementing those solutions. They want to see that return as quickly as possible. In-memory computing now is really used by most data-driven industries. Early in its history, and this is even pre-2017, in-memory computing usage was very heavily used in financial services and fintech. They really led the market there. Time is money often, and you could afford to make a larger investment into some kind of in-memory computing solution that was maybe more challenging. You had a bigger IT group to work with. It was worth the investment. It was worth the extra expense. But now, as this has entered more of the mainstream, it's become less expensive. There's easier to deploy solutions that are now available. Really seen a huge pickup within the non-financial services sectors. So transportation, logistics, e-commerce, retail, telecom, online business services, and more. It really followed in large numbers. So whereas financial services might have been more than half the market 5 or 10 years ago, now it's probably less than a quarter of the market in terms of just number of companies using in-memory computing technology. And there's so many more applications for in-memory computing that have evolved and are getting put in place by companies across a broad spectrum of industries. And not only that, it's really began to power a vast range of use cases. So whereas it was largely financial services focused 5 or 10 years ago, investment book of record, fraud detection, now it's grown into many more use cases: upsell, cross-sell opportunities, security, call management, route planning, recommendation engines, IoT platforms. The number of specific uses of in-memory computing have grown tremendously. And in-memory computing is really, as Gartner forecasts, has really entered the mainstream. It has a daily impact on people's lives. If you think about your interactions on a daily basis, many of your everyday interactions are driven by in-memory computing. If you're using your credit card, there's probably in-memory computing solution in there somewhere that's helping with fraud detection, it's helping with the payment processing, it's helping with the merchant payments. If you're using some connectivity solution, there's a good chance there's an in-memory computing solution in there somewhere that's helping with call routing or meeting management on the back end. If you're using a website, there's very possibly a in-memory computing solution that's helped drive the recommendation engine that's showing you the next page and highlighting different products for you. So in-memory computing is really, it's mainstream. It's everywhere. It's under the covers, so people aren't aware of it, but it's really having a daily impact on people's lives now. And interest in in-memory computing and users have really soared. So we ran the first in-memory computing summit in 2014 and had around 100 people. This year we're well over 1,000 registrants for this conference this year. So there's more than a 10x increase in in-memory computing summit registrants. We're also seeing large software and services vendors now active in this space. So you can tell from the sponsor list this year, as IBM and Intel and Oracle and Tech Mahindra, CJ, Olive Networks. There's the very large vendors that are involved with the in-memory computing space as it's matured and it's found more applicability to a broad range of companies and also on a very large scale. And there's very massive open source usage. So there's millions of monthly downloads of open source in-memory computing software solutions. There's been over 1 billion cumulative Docker pulls. So if you look at the different in-memory computing solutions and the Docker container pulls, over 1 billion. And you know, talking about one project we're familiar with, being GridGain, but Apache Ignite's also a top 10 Apache Software Foundation project. So there's over 350 Apache Software Foundation projects, and they rank the projects based on activity of user and developer mailing lists. And Ignite is up usually in the top 5, top 10 consistently for across all the Apache Ignite Software Foundation. So a few talks that you might find interesting for this for the conference here. We've got one about the power of in-memory computing from supercomputing to stream processing. That's a keynote from Scale Out. That'll be at 10:20 today. How to transparently scale out SQL databases by Imdal Data at noon today. And there's a talk about patterns of domain-driven design, which is by Oracle at 2:40 today. So those are all talks that you might want to check out. Something else that has happened, it's kind of just grown, but another major use case has emerged for in-memory computing. So we talked about digital transformation. We talked about those challenges with the disparate data sources, and what we've found is that while in-memory computing was originally largely about application acceleration, so it was take an application, insert some in-memory computing technology, speed it up, scale it out, and that was largely about in-memory data grids or potentially about in-memory databases. We've seen this whole new area evolve, which is what Gartner terms a data integration hub. They were kind of around, but they kind of became raised in awareness for everyone. And really became a thing. So Gartner's put a category around that, data integration hubs. People also call them smart data hubs or real-time operational data stores or API platforms. But what they do is they allow real-time access to disparate data across the enterprise. So this is actually a Gartner architectural schematic of a digital integration hub. What it is all about is taking data from a lot of different data sources, having some kind of synchronization layer, getting the data that you need, not all the data, but the pieces of data that you need into an in-memory computing platform in the middle, and having some API access so your applications can take advantage of that data and you can drive real-time business processes. And this tends to really be about in-memory data grids or in-memory data caches. They fill that part there between the synchronization layer and the API gateway in this particular drawing. There's some great talks that refer you to, a couple of them tomorrow. So there's going to be one on real-world transformation with the Z Digital Integration Hub. That's going to be a keynote by IBM and M&T Bank tomorrow at 10:15. And there's another talk by Zappin and IBM on an approach to progressive core modernization in banking. That's really about digital integration hubs as well. And that's at noon tomorrow. So I encourage you to attend those to learn a little bit more about what's going on with digital integration hubs and the mainframe. But there's many also uses for digital integration hubs and non-mainframe data. And some of those will be covered throughout different sessions during the conference. So something else that's going on today is we've moved from really kind of experimentation phase to implementation phase with in-memory computing technologies. And the solutions have moved from kind of difficult to use bleeding edge technologies into more deployment ready technologies. Tools and talent have become more critical. So it's really about implementation rather than trying to figure out exactly how to use this stuff. It's figuring out how to implement these types of solutions. And production and development tools have become increasingly important. So, good developer tools really help increase productivity, and they reduce the skills requirements for developers. And as you're moving into production, managing mission critical deployments requires production MMA tools. In fact, one of the things that we've done at GridGain this year is we introduced a major new product, the GridGain Control Center, which is just a major upgrade in terms of development and production management tools. That's something we'll be talking about later today. Hand in hand with the tools is talent demands have really skyrocketed. So more and more companies, more and more industries are starting to see the value of in-memory computing. They want to implement it into their processes. They want to digitally transform their business. And what that has caused is a shortage in people who are skilled in distributed in-memory computing. So, training has become critical so more people can get up to speed on those technologies. But also companies have responded by introducing in-memory computing platform as a service offerings and managed service offerings. So at GridGain, we introduced our GridGain Nebula managed service offering this year. So companies can just outsource the management maintenance of their in-memory computing production environments if they choose. And then we've also seen as I mentioned with the sponsors, we've seen large SIs now debuting IMC-centric services. So these large SIs like Tech Mahindra, CJ All Networks, TCS, these folks are coming in, they're starting to develop competencies at implementing these in-memory computing technologies within organizations, which really help offload and reduce that need for finding skills to hire. So there's a few interesting talks that come in to those two new products I mentioned. If you're interested in tools, there's a talk on analyzing, debugging Ignite applications for performance today at 3 p.m. And there's an engineering overview of the GridGain Nebula managed service breakout session here today at 11 a.m. as well, which I encourage you to consider attending. Another thing that we've seen is these related technologies have really dovetailed with the in-memory computing software solutions. So persistent memory has really blossomed. 3 years ago, it was something everyone was talking about, wasn't really generally available yet, but it is now. Interest in byte addressable memory usage is growing. The solutions to make persistent memory easier to fully utilize are emerging. So, it's not only the basic hardware technology, but also that next level of software that will make it much easier to tie into that. And it's also the evolution of existing software solutions to take advantage of persistent memory, which is all going on right now, which will help drive the adoption of the persistent memory. And then also there's integrations with key software solutions. That's now become common for in-memory computing software to integrate with other solutions. So, whether that's Kafka or Confluent for streaming data, whether it's Spark for unified analytics or Debezium for change data capture, integrations are becoming very common and very powerful parts of the in-memory computing landscape. There's a number of talks going on today and tomorrow about these different technologies around persistent memory in particular. We'll hear from a representative from Dell here right after this talk, talking about the Smart Data Acceleration Interface, which is a key component of persistent memory. We'll hear about using Intel Optane persistent memory for data read caching by Oracle at noon today. We'll hear about that layer of that enablement layer that works with persistent memory tomorrow in the big memory movement by Memverge in a keynote at 9:30. And also we'll hear them take a deeper dive, talking about memorizing the future with software-defined big memory services at 2 p.m. tomorrow. And then 2 p.m. today, we'll have a talk by Confluent talking about Apache Kafka's cloud-native future. So I hope you can attend some of those talks. They all tie in nicely with what's going on in the marketplace, and I think you'll find them very interesting. The other trend that's going on now is very interesting is data management technologies are really converging. So what we see now is traditionally disk-based databases are developing more in-memory features. In-memory computing platforms are developing multi-tiered computing capabilities. So, that's the capability to store data both in RAM and on disk and process no matter where the data lives. And then in-memory databases are continuing to enhance their disk-based features, things for like backup and disaster recovery, and also integrations. So all of that is creating kind of a convergence. Technologies are coming at this from different starting points, whether it's disk-based databases or purely in-memory solutions, but there's a lot of capabilities that are coming together into kind of common approaches to the challenges of lots of data and needing to process it in real time. And that really, part of that drove this definition, this category called in-memory computing platforms that Gartner defined, which is an in-memory computing platform is a solution that includes in-memory data grid, in-memory database, streaming analytics support, and also some other feature, be it machine learning or other capabilities. But it's really kind of this convergence that's going on that is resulting in that in-memory computing platform new category that is emerging. So a couple talks you might want to check out related to this by Oracle. They've got a database in memory powering the future of enterprise applications keynote tomorrow at 11. And they'll also be talking about the top 5 transformational technologies with Oracle's autonomous database today at 4 p.m. Of course, no surprise, one of the things that's going on is cloud computing continues to grow in importance. There's no surprise there. What is interesting, so I pulled up some data here from this Flexera 2020 State of the Cloud report, and they highlighted some of the challenges companies are having with cloud computing. 3 of those that I thought were noteworthy. One is a lack of resources and expertise. Not a big surprise, always a challenge. Highlights opportunities, perhaps for all the technical folks here on the call. But also managing multi-cloud deployments. So, nobody likes vendor lock. So being able to use multiple clouds, multiple vendors is a good thing, and being able to manage that effectively is something that many enterprises would like solutions to. And also just the whole issue of migrating to the cloud. That's one of the barriers to cloud adoption. If you look though at the graph on the right, you see, even though there's some challenges, the adoption of the public cloud continues to grow year over year. So in 2020, more companies were using AWS than in 2019. Azure, Google Cloud had a big pickup, Oracle Cloud sees growth, VMware Cloud on AWS. This cloud computing just continues to grow. It's clearly a wave that is moving along, and in-memory computing is going along with it. So one of the things that we see now is in-memory computing deployment options really are crossing boundaries. So with almost all solutions, there's support for on-premises, public or private cloud, or hybrid environment deployments. So if you're getting in-memory computing software today, you can probably deploy it anywhere you need to. The idea of cross data center backups and operations has also become crucial. So those capabilities are becoming mainstream within in-memory computing solutions. You really need to have multi-data center backups just for DR purposes and for reliability and uptime purposes. But then that can also begin to extend into those multi-cloud environments and being able to manage data across multiple data stores and data locations. And then really we're seeing the emergence of many in-memory computing solutions that are very cloud friendly. So they're leveraging Kubernetes, Docker, OpenShift, all the cloud related technologies. As those rapidly grow in popularity, in-memory computing is following along. There's a number of talks that you might find interesting in regard to this, the idea of cloud. One is this is a talk at 1 p.m. today on going cloud native, serverless applications with Ignite. Hazel Pest will be talking at 2 today on in-memory technologies journey to the cloud. tomorrow morning at 7:30, we have a talk by Gigaspaces on building a successful hybrid and multi-cloud strategy with an in-memory data fabric. And then at 8:30 tomorrow from mail.ru, we're talking about S3 from scratch, their cloud storage on in-memory database. So a number of talks that relate to cloud computing as well that I think you might find interesting. Okay, so finally, where does this bring us? So talking about tomorrow. So, what's coming for the future? One thing that is probably going to be true in the future is going to look like the past and the present. So I think we'll see a lot of the present trends will continue. So in-memory computing growth will continue in an expanding list of industries. It's already across many industries. I think what we'll see is adoption by more companies, but also smaller companies. So it's not just the largest companies with the biggest IT staffs who can do this. As the knowledge and the solution, as the knowledge diffuses and the solutions become easier, we'll start seeing mid-sized companies start deploying this. Small-sized companies start deploying in-memory computing to a greater and greater degree. The technology will also become easier to use as the vendors respond to this need to really focus on implementation rather than experimentation. There'll be an ongoing and continuous focus on making solutions easier. So you understand the architecture you want to create, and you can pick up the pieces that'll plug into that architecture and make it happen quickly, so you can get time to value will be shorter and shorter. There'll also be an expansion in the pool of knowledgeable in-memory computing practitioners. This is diffusing. More people are learning about it as more in-memory computing architects and developers and software vendor personnel come into the space, learn about it, learn how to use it. They'll spread that knowledge among more and more companies, and more and more people get trained on how to use this, how to use these technologies. We'll also see data integration hubs become mainstream. A lot of companies are using them today. In many cases, they may have developed it for a particular specific problem that they were trying to solve and not really thought about as a data integration hub. But in fact, they've developed data integration hubs, and there's that concept of these data integration hubs and creating those 360-degree views across disparate data sources in the enterprise become more and more common. You really see this become a mainstream technology. So digital transformation will really be an overwhelming force to drive this. As companies digitally transform, digital integration hubs are really a key enabling technology that'll make it possible for companies to digitally transform their business and really deliver those fantastic customer experiences. It's going to drive those real-time business processes that are based on 360-degree customer views. And as that becomes a requirement for business success, as companies have to do it just to keep up with their competitors, it's really going to continue to accelerate the adoption of these types of technologies. You're going to find, I think, over time, they're just going to be easier to implement commercial digital integration hub solutions that will emerge. I talked about those couple of IBM talks. It's an interesting case study. So there's a commercial digital integration hub solution there that's beginning to emerge, and there's an ecosystem that's starting to form about it. And I think you'll see that more and more as companies realize, hey, we can help other companies reduce their time to value by introducing solutions that will make it much easier for them to implement and not have to go through all the pain of learning every bit of all these different technologies. And then we'll continue to see the adoption of persistent memory, and I think that'll grow. There's been tremendous interest in it for multiple years now. The technology's here. Now it's getting to the implementation phase. So it's understanding what the technology is, but it's really then exploring those byte addressable persistent memories, persistent memory options, and evolving those into adopted solutions. It's probably most hardware solutions. I would expect persistent memory prices are going to fall, which will also help reduce the barriers to adoption. And technologies that enable persistent memory usage will advance. So we talked about a couple of talks tomorrow by Memverge. I think that's one example of the kind of advancement that's going on there. So finally, what does this mean for you? So the fact that you're here is great. Here at the conference, this was a recent Harvard Business Review article from May of this year, but they make the point that digital transformation is about people, not technology, which, something to really think about. They say we expect digital transformation to be an even bigger imperative for organizations in the short term. They're talking specifically about the impact of COVID-19, but the view they put forth was digital transformation is less about technology and more about people, because you can pretty much buy any technology, but your ability to adapt to an even more digital future depends on developing the next generation of skills, closing that gap between talent supply and demand, and future-proofing your own and others' potential. So, I encourage you. This is, a great 3 days. I hope you hit the training session yesterday. The training sessions, but there's some some great opportunities to really expand your skills, expand whether you're an architect, a developer, an implementation professional, someone who's working in developing these technologies. Grow your skills. They're going to be in greater and greater and greater demand. The more you know, the better off you'll be, both personally and professionally. So I encourage you to take full advantage of the conference. We are posting the training sessions from yesterday, so if you missed those, there was one on setting up Apache Ignite managing and monitoring a solution with GridGain Control Center. There was one on training for Apache Ignite as an in-memory database, and then talk by Scale Out Software, how to use real-time digital twins to track 1 million data sources. So those will be online on the conference website. If you missed them and you'd like to attend, I encourage you to do so. It's great talks throughout the rest of the conference, and I encourage you to take advantage of it and enjoy yourselves. And there's a lot to learn. I think the future is very bright for the technology and for all of us.